In this video, we'll have introduction to queue data structure. Queue is a logical data structure. It works on discipline FIFO, first in, first out. Like in daily life, we find various places we form queue, like people are standing in a queue to avail some services or for submitting their application, or cars are standing in a queue at a toll booth, or your application is in queue. Even our phone calls, sometimes if the lines are busy, we get a message that you are in queue, please wait. Or customer care, if you are calling, then we also get a message that you are in queue, our customer representatives are busy, please wait. So we find queue at various places. So queue is commonly used in various applications. In same way, in various algorithms, queue is used. So queue is one of the basic data structure. So here is an example of a queue showing people are standing in a queue, and this is like a counter. So they are waiting in a queue to get their turn to avail some services or do whatever the work they have. So this works on discipline FIFO, that is first in, first out. Queue will have two ends, like this end is called as front end and this is called as rear end. If a person wants to join a queue, then he should come and stand at the end of a queue, that is rear end. So I can call it as insert. So insertion is done at rear end. And if this person has finished his work at the counter, then he can go out from the queue. So this we can call it as a delete, and deletion is done from front end. So insertion is done from one end and deletion is done from another end. So both the ends are used here. Whereas if you remember in the stack, like this is a can, so insertion is done from this opening and the deletion is also done from same opening. If you have some balls in the can, this is the only end from where you insert, and from this end only you can delete. But here in queue, you insert at rear end and delete from front end. So let us look at ADT of a queue, abstract data type of queue. Let us look at Queue ADT. First of all, we will look at data. First of all, we need is space for storing elements or storing objects. Next, we need a front pointer that is useful for deleting the elements. It may be pointing upon or before the first element, but it is used for deletion of elements. The next thing we need is a rear pointer that is used for inserting the element. It may be pointing upon last element or after the last element, but it is used for insertion. So this is about data that we need: space, front pointer and rear pointer. Now let us look at the operations on a queue. First operation is enqueue. Enqueue means inserting an element in a queue. So insertion is done from rear end. Like if a person wants to stand in a queue, then he has to come and stand here at rear end. Then second operation is a dequeue. Dequeue means deleting an element. Deleting an element is done from front end. Means if a person has to leave a queue, then he should go out from here once his work has finished. Then the other simple function like is empty, checking whether queue is empty or not, and is full if the queue is full or not. Then if at all, if you want, you can write down other functions also, knowing what is the first element in the queue, knowing what is the last element in the queue. If at all, you can add them. And if you want, you can write more functions like displaying a queue or counting the number of elements in a queue. These type of operations are your choice as per your requirement. So this is the ADT of a queue. Now next, queue can be implemented using two physical data structures that are array and linked list. So queue can be implemented using any of these two data structure, array as well as linked list. So we have to learn how to implement a queue using array, then how to implementing a queue using linked list. That's all in introduction. So the next video will learn how to implement a queue using array.